Hello students, today I am going to discuss about the topic metals and non-metals, which is basically in class 8 plus NCERT and chapter number something 5. Okay, so this is a very interesting and important chapter, and also is very important for in the case of chemistry, basic substance. So being, before beginning of the chapter, let us know what is metals and what is non-metal. You already are very similar among these two words, metals and non-metals. Basically metals, you know that what are metals: iron, copper, gold. These are all metals, and oxygen, nitrogen, sulfur, phosphorus, these are non-metals, as you all know that basic idea. But what is actually on the what in the on what basis the metals and non-metals are divided partly? These are basically divided in the basis of atomic structure of metals and non-metals, atomic structures of element, which you all study in higher classes when you all study the periodic table, which is the table of all the elements, and the elements are arranged with their respective atomic numbers. So okay, I tell you about the metals and non-metals very briefly. Okay, the definitions, which property is known as metals and which property is known as non-metals. I am telling you very briefly about that concept, very concept. But what are so basically what are the metals? We all know that the every atoms, basically every compound or every particles are made of basic properties or basic structures that are called atoms. And if we divide an atom, we get three types of elements, that are electrons, protons and neutrons. And protons and neutrons together form the core of the atom, that is called nucleus, and the electrons are revolving around the nucleus in different orbits. Okay, now what are metals? What are the basis, what are how we identify the metals on the basis of its atomic structure? Okay, so saying very shortly, metals are usually that elements in uh, which the atom of these elements, the metal elements, and basically the last orbit of the, that means the valence orbit or valence shell of the metals, the number of electrons are basically 1, 2 and 3. These, if the number of electrons, these electrons are called valence electrons. Valence electrons means what? Valence electrons mean the electrons which are present at the last, at the outermost shell of an atom. Suppose an atom consists of this is the nucleus of an atom, and an atom consists of two shells. So this is the second shell, and the shells are named as what? K, L, M, N and so on. Okay, so the suppose as an atom has two shells where K and L. So L is the outermost orbit, and the number of electrons present in the L orbit is the are the valence electrons of that atom. So if an atom of an element consists this number of valence electron, then the atom is called then the element is known as metals. Similarly, if the valence number of valence electron of an atom becomes 4, 5, 6 and 7, these are called non-metals. Okay, the last the number of electrons on the last orbit, on the outermost orbit of an atom becomes 4, 5 and 6 and 7 in numbers, then that element is known as non-metals. If when we look at a periodic table, we can see that a periodic table, suppose this is a periodic table, here's the sum of the rows and here's the element. Okay, these are the columns and there are the various elements. going down to this, and again in the second column, in the third row, sorry, second row, in the third row, and the fourth row. Basically in the first column, that is this column, these columns, first three columns are consist of metals, and the other four columns, that is fourth, fifth, sixth, and seventh columns are consist of non-metals, and the eighth column is consist of noble gas, which are not metals and not non-metals. They are different types of particles, different types of element, which is the another topic. Okay, so these are the periodic table, and a periodic table also defines various other properties of elements. There are various other properties. Okay, so that's another topic. So what is the basic idea about metals and non-metals? The basic idea about metals and non-metals is that the metals are the elements in which the number of valence electrons in the atoms of metals basically are the number of 1, 2, and 3, so that they can reduce that electron, they can exert electrons and become stable. Okay, again in non-metals the atoms consist of the valence electrons of number 4, 5, 6, 7, and they gain the electrons and becomes stable. So metals are the properties to lose and lose electrons, and non-metals are the have a tendency to gain the electrons to become stable, basically to make the octet formation of its atom. Okay, so these are the basic topics of metals and non-metals. So you don't have to know right now about the inner topics, inner definitions, inner properties of metals and non-metals, and on the basis of atomic structure. So in the you are going to know about the overall study of metals and non-metals. What are their basic properties? What are the basic reactions of them with acids, with base, with water, with oxygen, etc., etc., and we are going to discuss it throughout the time. Okay, so first of all, the properties of metals. Okay, metals and non-metals. So these are the mainly properties of metals. Here you can see some of these words: malleability, conductivity, ductility, sonorous, lustrous. Okay, so I am going to tell you part by part about these topics. Okay, so first of all, malleability. Malleability is what? Malleability is nothing but the property of the physical property. They are all the physical properties. Okay, the properties of an element. Okay, of an element to make it a thin sheet. Okay, if and suppose if this element is cylindrical in shape, and if we beat it by some things, then if the property of the element to become a thin sheet. Okay, is known as the malleability. So generally you already have in your mind that metals are malleable. The elements that have the property of malleability are called the malleable property. So what are the malleable? Whose are the malleable? Metals are malleable because metals can be beaten into thin sheets. If you already know that various things in around us are made of metals and made of thin sheets. For example, cars, aeroplanes, trains, the bogies of trains, aeroplanes, and cars are made of metals and of thin sheets because they are malleable. They cannot break if beating. Okay, but non-metals are not malleable because if we beat a non-metal, then it will break down and not become a thin sheet. It will break up. Okay, so these are the malleability. Second is conductivity. Conductivity is what? Conductivity is nothing but the physical property of an element to conduct electricity or heat. Those elements who can conduct electricity, who can carry electricity, is called the good conductor of electricity, and who can carry the carries or conduct heat energy is called the good conductor of heat energy. So basically metals are good conductors of both electricity and heat energy, and non-metals are generally not good conductors of electricity. Exceptional, there are exceptional in both the cases. Okay, I will discuss it throughout. Okay, so next part is ductility. What is ductility? Ductility is very much similar to the malleability. In malleability, in the property of malleability, the malleability is a physical property, as I say that the property of an element to be beaten into a thin sheet. Here, the ductility is nothing but the property, the physical property of an element to make it a wire. Okay, a wire. Okay, this is the property which is called ductility. Similarly, malleability occurs in metals. Metals are malleable, and similarly metals are also ductile. The element which can show ductility is called ductile elements. Metals are ductile and non-metals are non-ductile. Okay. So next point is sonorous. Sonorous means the property. You all know that if a metal is heated, then it produces sound. Okay. If iron bar or any metal substance is heated, heated, then it can produce a sound. So this property is called the sonorous property, and which is basically happens for in the case of metals, and for non-metals they are not sonorous. If for example carbon, for example coal is obviously carbon matters. The elements in coals are nothing but carbon. So if you beat a carbon, if you beat a coal, if you beat a piece of coal, then what will you see? If the coal is malleable, if you can you beat the coal into a thin sheet? No. So these are the proof of first property, that non-metals are not malleable. If coals and various non-metals are non-conductor of electricity and heat, so these are they are core conductor. Ductility: can you make a wire from a coal piece? No. So they are non-ductile. If you beat the coal piece, can you hear a sound? Can you produce a sound? No. So they are non-sonorous. And the very last property is lustrous. Lustrous means shiny or glamorous or glossy. The metals are always, that metals are glossy, glamorous in nature. They can shine. Okay, but non-metals, coals, can shine. They are 98% pure black body. Okay, so they are non-lustrous. Lustrous means shiny, nothing else more than that. So these are the basic properties, and after all, metals are hard compared to the non-metals. Non-metals are not so hard as metals. Okay, so these are the basic properties of metals and non-metals. Here are some exceptional cases which I will tell you. So as I know that metals are hard, but not all metals are hard. There are exceptional case for metals which are not hard, which are soft. Those metals are sodium, Na, and K, that means potassium. Sodium and potassium are not so hard, they are soft. Okay, and metals are, you all know that metals are hard, metals are solid in state, but only one metals are in liquid in room temperature. Okay, normal room temperature, only liquid metals is mercury. Okay, mercury is liquid in nature. Okay, and conductor. Okay, one more exceptional. As I say that non-metals are poor conductor of heat and electricity, but one exceptional case, that is graphite. Graphite is a substance. Graphite is basically obtained from coal. So graphite is non-metal, but it is a good conductor of heat and electricity both. Okay, so these are the mainly exceptional cases for metals and non-metals, and these are the properties of metals and non-metals, and the basic properties on the basis of atomic structure, as I am already discussed very shortly, very briefly in this part. So coming to the next part, that is the reactions of metals and non-metals with various substances. Okay, so I tell you about the reactions, various reactions of metals and non-metals with various things. First of all, the reactions of metals with oxygen. Okay, basically reactivity in reactivity series, reaction, the tendency of reactions is of metals are that are greater than that of non-metals. So now, okay, so with oxygen, the reactions of oxygen with Fe means ferrous, that is iron, which is a metal. So if metal is reacted, it reacts with oxygen in the presence of uh, air, moist air, means basically moist air means the water droplets, the air contains water droplets basically in water. So in the reactions we add a substance which is water. So what happens when iron reacts with oxygen in the presence of moist air open? We obtain the oxides of ferrous, that is ferrous oxide Fe2O3, which is known as rust. Okay, so rust is basically nothing but the reactions of reactions between iron and oxygen with the presence of water or moist air is occurs the rust, which is a coating over the iron substances, and the iron is gradually decaying. It's gradually decaying after reactions. Okay, this is the reactions of iron with oxygen. Okay, there is many preventions for rusting. For rusting, we coat iron materials with non-metallic oxides. Non-metallic oxides. There are non-metallic oxides also, which does not so that the oxygen cannot came in contact with the pure iron. Okay, so these are the coatings. Okay, but pure iron reacts oxygen with the presence of water, produce iron oxide, which is rust, and then the iron is gradually decaying. Okay, coming to the next part, that is magnesium. Magnesium is also a metal. When magnesium reacts with oxygen, magnesium basically reacts with oxygen, and the reactions is exothermic in nature. That is, magnesium and oxygen when reacts, it reacts with burning. Okay, it reacts with, when reaction occurs, a burning also happens, and forms magnesium oxide. Basically, all the metals which reacts with oxygen forms the oxides of that particular metals. So here the oxides of ferrous, here the oxide of magnesium. Okay, so this equation is important because this is the exothermic equations, example of exothermic equations where heat is generated with burning occurring. Okay, so next come to the copper. Copper is also a metal. Copper also reacts with oxygen, which is very much similar to iron. There is also a coating, also a green coating occurs over the copper, which is copper hydroxide and copper carbonate occurs. So copper reacts with oxygen with the presence of moist air. So moist air means basically water, and carbon dioxide also reacts. Okay, and produce copper hydroxide and copper carbonate, and this copper hydroxide is nothing but a green coating over the dull green coating of copper material. Okay, and the copper is gradually decaying, similar to that of iron. Okay. Next come with the reactions with acids. Okay, metals react with acids and produce hydrogen gas with occurring a pop sound. The pop sound means occurring a sound, The sound means the produce of hydrogen gas, which is gone through the air, uh, forming sound. Okay, so iron when reacts with H2SO4, which is sulfuric acid, forms ferrous sulfate, FeSO4, and hydrogen gas. This is a double displacement. This is a displacement reaction. What is displacement reaction? I am discussing it in this video. Okay. Again, if iron reacts with HCl, which is hydrochloric acid, forms ferrous chloride, and hydrogen gas is produced. Okay, this is a redox reactions. Basically, every reaction is also redox reactions. What are reduction? You do not have to know right now. Okay. After coming to the next topic, that is metallic oxides, means these oxides that forms, these are basically basic in nature. Means these oxides turns the red litmus paper into blue. Okay, so which shows that these oxides are basic in nature, base. Okay, and non-metallic oxides similarly for non-metals also reacts with oxygen and forms various oxides, non-metallic oxides, and they are acidic in nature. Okay, for example, sulfur is a non-metal which reacts with oxygen and produce sulfur dioxide, which is basically very dangerous pollutant substance. And this sulfur dioxide, when dissolved in water, produce H2SO4, that is sulfuric acid. It is a very strong acid, and this is acidic. Obviously, sulfuric acid is acid, and it turns blue litmus into red. So these are the non-metallic oxide is acidic in nature. Okay, so here are some extra topics in this chapter. That is sodium and kerosene, means not reaction with sodium and kerosene. Why sodium is put or kept into kerosene? Sodium is kept into kerosene because in open air sodium is a metal and very reactive metals. Okay, if it kept in open air, it can react with oxygen of the air and produce its oxides. So for preventing the these reactions of sodium and oxygen, it is kept into kerosene. Similarly, phosphorus is also kept in water. Phosphorus is again also a very reactive materials. It basically phosphorus when put in open air, it burns. Okay, it burns. Okay, so phosphorus is kept in water, is dissolved in water for make not for the prevention of that oxygen. Basically, burning happens when where burning happens, there is oxygen present. Oxygen present in the air, and with the presence of air, phosphorus burns with oxygen. Phosphorus is a non-metal, and it burns in oxygen, in the air of oxygen present in the air, and forms it oxides. Okay, in open air. So these two things, these sodium metals and phosphorus non-metals, are kept in kerosenes and water respectively. Okay. So these are all the these not all these are the basic some of the examples of metals and non-metals. Non-metals also reacts with acids and produce hydrogen gas. Okay, but the equations are much more complex. Metals reacts with base, also produce hydrogen gas. Okay. If Fe plus suppose Fe plus NaOH, it also produce hydrogen gas with Fe Na something NaOH equal to something at one type of substance here produced. Is a very complex substance, but hydrogen gas is also produced. Okay. This is sodium hydroxide, this is the base, okay, or caustic soda. So coming to the next point and the very important part of this chapter, that is displacement reaction. What is displacement reaction? What are the reactivity series of metals? What are the total genes of displacement reaction? I am covering through upcoming time through this video. Okay. Okay, coming to the next topic, that is the displacement reaction. So what is the displacement reaction is basically uh, displacement reaction is nothing but if in a reaction displacement reactions occur mainly between a metal and salt of another metal. In this reaction, the metal displaces the another metal from its compound or from its salt and takes its place and leave it single. Okay. For example, look at the reaction. Zn means zinc plus CuSO4, that is copper sulfate. This is a sulfate salt of copper. When reacts together, we form ZnSO4. They form ZnSO4 plus Cu, means zinc sulfate plus copper. That means zinc replaces copper from its compound and takes its place, leaving copper single. Okay. Similarly, ferrous, that is iron, when reacts with copper sulfate, it also displaces copper from its compound, from its salt, and takes its place and becomes FeSO4, ferrous sulfate, and leaving behind copper single. Okay. But similarly, zinc ZnSO4 plus Fe, this is also reactions between a metal and salt of a metal. Zinc is also a metal and ferrous iron is also a metal, and this is a salt of zinc and this is ferrous. So basically, according to this relation, Fe also the reactions, the product becomes FeSO4 plus Zn. Okay, but this reaction does not take place. There is no reaction between these two substances, these two reactants. Why? Here comes a rule, and according to a series which is called the reactivity series of metals. These are the reactivity. This is a reactivity series of metals, where you can see the elements of there is some elements. Okay, on the top of this series lies K, that is potassium, after then sodium, then calcium, then magnesium, aluminium, zinc, iron, lead. This is lead. Okay, lead, hydrogen, copper, Hg means mercury, which is liquid. That's exceptional case and already discussed through. Then this is argentum, or basically silver. Okay, and then after then the last is aurum or gold. Okay, this is the reactivity series. According to the series, when we going downwards, the reactivity of that metals, of these all are metals, of the metals decrease when we going downwards. That means the reactive sodium is less reactive than potassium. Basically, potassium is the most reactive material, most reactive, and the last, that is gold, is least reactive. So basically, in according to the series, the rule is a metal can displace the another metal from its compound if it lies in the lies above from that metal in this series. In now you look that this is copper sulfate. So basically, zinc and copper lies above copper. Zinc lies above copper, so zinc is more reactive than copper. So zinc is more reactive than copper, so zinc can replace copper from its compound and makes it free or single. Okay, but here zinc sulfate and ferrous iron. So zinc and ferrous. Okay, zinc and ferrous. Zinc lies above, just above ferrous. That means zinc is more reactive than ferrous. So ferrous cannot replace zinc from its oxide because ferrous is less reactive than zinc. This is the rule for displacement reaction, and this is according to the series which is called the reactivity series. Okay, so these are the basic displacement reactions about for this for class 8 standard. Okay, so this is very important part, and this series is also very important for various reactions. So now I hope that all the you all are aware with these topics, and also another part remains now, that is the use of metals and non-metals. These are very basic things. You all knows that metals are used to make strong things, that is to make airplanes, trains, trucks, and very hard things around us. And non-metals are used in various, also there are use of non-metals. Non-metals are used in medical antiseptics, and there are others also uses. You can go through the book. Okay, so these are all the topics about metals and non-metals for class 8 standard. Hope you can enjoy, you can learn something about these topics from my video. Okay, so good night.